Today we will begin with an important type of sequences, and the sequences that we will be discussing today are known to be Cauchy sequences. And you will see that there is a definite relation between convergent and Cauchy sequences. Indeed, they are same. So, what is a Cauchy sequence? What is a Cauchy sequence? Let us take a sequence xn be a sequence of real numbers we say that this sequence is Cauchy if for each positive number epsilon there exists a number, a natural number depending upon epsilon, such that the distance of the terms of the sequence from each other, this is the distance of the nth term and the distance of mth term, is less than epsilon for all n and m greater than or equal to n epsilon. So this is a Cauchy sequence. What it says that as after finitely many terms, a sequence is a Cauchy sequence if after finitely many terms the distance of the terms of the sequence becomes smaller and smaller. The terms become closer and closer to each other. This is what it is says, and this is how that means if you have let me try to make some picture. You have this real line here, but it says that a sequence is Cauchy sequence. Suppose you have x1 here, you will have x2 here, so up to after x and epsilon, the distance of the terms has to be less than epsilon from each other. That means if I fix some term here, and then let this be the distance, this be the interval or epsilon neighborhood, what you say. This is some term and all those terms are going to lie somewhere here. There is not much distance between those terms. They all are somewhere close to each other. So such a sequence is known as a Cauchy sequence. Let us look at this following example. Uh, First thing I'm going to tell you is that this sequence 1 by n is a Cauchy sequence, and we also know that this is a convergent sequence also. But let me see that this is a Cauchy sequence. How to show that this is a Cauchy sequence? Let us choose some epsilon greater than 0. Then what we want to show? We want to show that the distance of the terms, nth term and some mth term, this distance needs to be less than epsilon for all n m greater than or equal to some number which we have to establish whose existence. Okay, now how to find this n, capital N? Let us see first what do we have. We have this Archimedean property. By Archimedean property, I can choose a number n depending upon epsilon such that 1 upon n epsilon is less than epsilon. This is how I can apply Archimedean property. Then you see that for any number n which is greater than n epsilon, we will have this 1 upon n, reciprocal will be less than 1 by n epsilon. And if you have chosen this n epsilon to be a number whose reciprocal is less than epsilon, then 1 by n is also going to be less than epsilon. But I'm just not making it less than only epsilon. I'm just choosing this to be epsilon by 2, just to have. Now what it gives me, from, let us, this box thing is something that we want to achieve, but what we have obtained till now, we have obtained a natural number, and which I'm denoting by n epsilon, such that whose reciprocal is less than half of the epsilon. Now let us look at this 1 upon n minus 1 upon m, where I'm choosing n and m to be numbers which are greater than this n epsilon. Now you just apply the triangle inequality, and by triangle inequality I will have this to be less than or equal to 1 by n plus 1 by m, and 1 by n is less than 1 by n epsilon. This 1 by m is also less than 1 by n epsilon, because they are bigger than this number, and but 1 by n epsilon is less than 1 by epsilon by half, so it has to be epsilon by 2 plus epsilon by 2. This implies that this distance 1 upon n minus 1 by m is less than this right hand side there in second last line is now epsilon, and this is true for every n m greater than or equal to n epsilon. And this completes that this sequence is a Cauchy sequence. Is it okay? Is it okay
Yes,
that
sir.
this is a Cauchy sequence? Okay. So, what we have to prove a principle that is known as Cauchy principle or Cauchy criterion. But for that, we require a lemma, and that lemma will give us a property of a Cauchy sequence. And the property of this Cauchy sequence that this lemma is going to give us is that a Cauchy sequence is a bounded sequence. A Cauchy sequence is bounded. We have to first prove this thing, that a Cauchy sequence is a bounded sequence. Let us see कि Cauchy sequence bounded sequence कैसे होती है. ठीक है, तो let us take a Cauchy sequence. Let xn be a Cauchy sequence, and I'm going to take epsilon to be 1. Then apply the definition of the Cauchy sequence. It says that then there is some number n depending upon epsilon 1 layering up and 1 greater than 0, such that what do we have, this xn minus xm is less than 1 for all n m greater than or equal to n1. In particular, if I take m to be equal to this capital N, but I get for m to be n1, still this inequality will hold, because this is true for every greater n and m greater than or equal to this capital N. I will have x capital N is less than 1 for all n m greater than or equal to n1. Now, for any n I don't need here nm. For any n greater than or equal to n, let us look at this modulus of this term of the sequence corresponding to this n. What I'm going to do now, I'm going to add something and then impromptu subtract that number from there also, so that this is something that I can do here. And now you apply the triangle inequality. By triangle inequality, it gives me that this is x n minus x capital N plus mod of x capital N. And the you have chosen this small n to be greater than or equal to n, and for that particular choice of this n, the distance of the nth term from this xn is less than 1. So this is less than 1 plus mod of xn. So till now, what we have this inequality that modulus of size of this term of a sequence nth term is less than 1 plus mod of x capital N for every n greater than or equal to n. So we have these terms. They are less than this now, but there are still terms about which we know nothing. That means, for example, up to these terms, we know nothing about these terms x1 up to xn minus 1. We do not know whether their modulus is their absolute value is also less than or equal to this 1 plus xn or not. But for that, let us choose a number m, which is maximum of absolute value of x1 so on up to absolute value of xn minus 1, and also this number 1 plus xn. Now you see, now you see that mod of xn, n is either a number less than n, capital N. If it is less than capital N, then still it is less than or equal to m. And even if it is greater than or equal to this capital N, then it is its modulo, its absolute value is less than 1 plus mod of absolute value of xn, and but capital M that I have defined here is a number which is larger than this number also. Hence, in any choice, whatever n you choose, you choose, the this absolute value is going to be less than or equal to m, and this is what gives us that this sequence is a bounded sequence. This shows that this sequence is a bounded sequence, is a bounded sequence. So this is done now. That the thing that you know till now about Cauchy sequences is that a Cauchy sequence is always a bounded sequence. And now here we have a
सर
powerful result. हाँ जी बोलो.
सर ये प्लीज एक बार फिर से रिपीट करना ये स्टेप जहाँ से एम से आपने लिया
अच्छा, ये m को कैपिटल रखा ना. अब देखिए m
ये सर
मैक्सिमम है इन सारी टर्म्स का, क्योंकि अब हमारे पास क्या, हमें चाहिए कि कोई एक ऐसा नंबर चाहिए जिसके लिए आपके पास मॉड ऑफ एक्स एन लेस देन और इक्वल टू दैट नंबर हो जाए. तो अभी मॉड ऑफ एक्स एन हमारे पास लेस देन हमारे पास 1 प्लस ये कैपिटल एन जो है ये फिक्स है. तो दिस इज अ सम नंबर कांस्टेंट, दिस इज सम कांस्टेंट. ठीक है. तो फिर उसके बाद कुछ टर्म्स बचती हैं x1 अप टू xn माइनस 1. तो हम क्या कर लेते हैं, उन सब टर्म्स का भी मैक्सिमम ले लेते हैं, सो दैट अब आपके पास जितनी भी टर्म्स बचेंगी सीक्वेंस के पीछे, तो वो सारी की सारी टर्म्स उस मैक्सिमम से छोटी होंगी, क्योंकि बाकी n माइनस 1 तक ही टर्म्स ले रहा हूं मैं. उसके बाद जैसे फॉर एग्जांपल अगर आप देखो, तो आई हैवंट इस मैक्सिमम में मैं ये वाली टर्म नहीं ले रहा हूँ. जैसे फॉर एग्जांपल एक्स एन प्लस 1 है, ये नहीं ले रहा हूँ. ये इसलिए नहीं ले रहा हूँ क्योंकि इसका इसका इसके लिए एस्टिमेट मेरे पास ये वाली टर्म दे रही है ना, क्योंकि जब n जैसे ही n आपके पास कैपिटल N से बड़ा हो जाता है, तो उस केस में उसका मॉडुलस जो होगा, इसका मॉडुलस आपके पास लेस देन 1 प्लस मॉड ऑफ एक्स एन हो जाएगा, ये एन मूव नहीं करेंगे। ये इसी तरह से n+2 होगा, n+3, सो ऑन, उन सारी टर्म्स के लिए ये लेस देन, इसलिए हम सिर्फ 1 से लेकर n-1 तक लेंगे। बाकी सारी टर्म्स का हमें मालूम है कि वो इस वाले नंबर से छोटी हैं, तो सारी संभाल है इस वाले नंबर से। और फिर क्या होगा कि फिर जब हमने मैक्सिमम लिया, इसका भी मैक्सिमम और उन सारे नंबर्स का मैक्सिमम, तो दैट मीन ये जो m अब है, ये m इस x1 से भी बड़ा है, xn-1 से भी बड़ा है, 1 प्लस xn से भी बड़ा है। तो उससे क्या होगा कि आपके पास जो हर एक टर्म जो सीक्वेंस की होगी, क्योंकि दो दो ही पॉसिबिलिटीज है, जब आप कोई सीक्वेंस ले लोगे xn, तो या तो xn क्या होगा, या तो xn विल बी x1 सो ऑन अप टू xn-1 में से होगा, ठीक है। या तो
यस सर।
दूसरी पॉसिबिलिटी कि xn में जो n है आपके पास, वो ग्रेटर देन और इक्वल टू n होगा। अब x1 x2 सो ऑन अप टू xn-1 में से होगा, तो उस केस में तो जो मॉडुलस होगा इसका, तो वो किस कैपिटल M से लेस ही होगा ना, क्योंकि कैपिटल M इन सब का मैक्सिमम है, वो लेस होगा। अगर n कैपिटल N से बड़ा होगा, तो उस केस में उसका मॉडुलस जो होगा वो लेस देन होता है 1 प्लस xn से। लेकिन उस वक्त अभी अभी क्या है, कैपिटल M जो चूज करा, कैपिटल M इज ग्रेटर देन और इक्वल टू दिस नंबर आल्सो, तो उस केस में भी आपके पास मॉड ऑफ xn जो होगा वो लेस देन कैपिटल M से होगा। तो इसीलिए इन एवरी सिचुएशन वट एवर एन यू चूज, दिस इज लेस देन इक्वल टू M। इज इट ओके?
यस सर।
So okay, let's look at now this Cauchy sequence, Cauchy criterion. Cauchy criterion. Cauchy criterion says that a sequence of real numbers, a sequence of real numbers is Cauchy if and only if it is convergent. If and only if it is convergent. So this is the powerful thing about Cauchy criterion, that it gives you an alternate to the convergent sequences. Now, if you want to identify whether a sequence is convergent or not, what you have to do, you have to just establish whether the sequence is Cauchy or not without knowing that whatever its limit is. So उसकी limit जानने की कोई जरूरत नहीं है, you just देखिए कि अगर sequence की terms आपस में close आती जाती हैं, so they are Cauchy sequences, and hence that is a convergent sequence. Let us try to see its proof. First, suppose that the sequence is a convergent sequence. Suppose that xn is a convergent and मान लेते हैं कि इसकी लिमिट जो है, this sequence is converging to some number x. Now we have to establish that this is a Cauchy sequence, and for Cauchy sequence, let epsilon be a positive number, and since the sequence is convergent, so we can convert using the definition of the convergence. There exists a number n greater than 0 such that we have this thing xn minus x will be less than epsilon half for every n greater than or equal to, and this is the definition of Cauchy convergent sequence. Now let us choose n and m to be greater than or equal to this n. ये n जो अभी आप ऊपर मिला है. Then let us look at this distance xn minus xm. What I'm going to do here, I'm going to add x and I'm going to subtract x also. And now you use the triangle inequality. Triangle inequality will give us that this is less than or equal to xn minus x plus x minus xm. And now see what you have. You have this n is greater than or equal to capital N, and whenever n is greater than or equal to capital N, what you have this distance of nth term from x to be smaller than epsilon by 2, and similarly this m is also greater than or equal to n, hence the distance has to be less than epsilon by 2, and this is equal to epsilon. So finally what you got here that xn minus xm is less than epsilon for the distance of these two terms. So whenever n and m is greater than or equal to n is less than epsilon, and this proves that this sequence xn is Cauchy sequence. This is what we need to show, that the distance of the terms is arbitrarily small as we move ahead. So one way it is true that whenever you have a sequence which is convergent, then it is a Cauchy sequence. Now let's look at this converse part, that suppose we have a sequence, suppose that xn is a Cauchy sequence, and we have to establish that this sequence is convergent, is a Cauchy sequence. And we have to show that it is a convergent sequence, but to reach there we have to use some results, and the first thing that we are going to use, we just proved a lemma which proved that which tells us that this sequence is a bounded sequence, Cauchy sequence is a bounded sequence. Then xn is a bounded sequence, is a bounded sequence. lemma जो अभी प्रूफ करा मैंने, this follows from lemma. And now we have a bounded sequence, and now I can use Bolzano-Weierstrass theorem for sequences. And what is the Bolzano-Weierstrass theorem for sequences? Which this states that a bounded sequence has a convergent subsequence. So by Bolzano-Weierstrass theorem for sequences, this sequence has a convergent subsequence x, and because it's bounded, has a convergent subsequence. It has a convergent subsequence. Say that subsequence is x and k, and we also, since it is a convergent, it will have a limit, and let that limit be denoted by x, and let its limit be x. Okay, we have this thing. Now what we are going to do now, we are going to know, we have what information we have till now. We have a sequence which is Cauchy, and we have been able to extract a convergent subsequence out of it. And now we are going to, and because of that convergent subsequence, we got a limit of that kind of subsequence, and we are going to prove that this limit is something to which this whole sequence is converging. We have to show this thing, and to show that this converges to this, let us begin with some epsilon positive. And now you have this epsilon positive, then we have this number, since sequence is Cauchy, so what you will have, I will have xn minus xm is less than, let me take it to be epsilon by 2 for all n m greater than or equal to some number. Let me, yeah, okay, this is an epsilon. Okay, this is 2. Let this equation be something denoted by star. Also, we have this sequence x and k, and subsequence, this sequence is convergent, and so using the definition of convergence of this subsequence, I can say that there exists a number n sub k. This will also depend upon epsilon greater than 0, such that what we'll have, we will have this thing, the distance x and k minus x will be less than epsilon by 2 for all n k greater than or equal to this number n k. See, now we have these two numbers. One is n in this equation star, and I have another number nk. Okay, so what do we have? Clearly, since these are the two natural numbers, either one is bigger than or the other is bigger than. But what we are going to assume, we are going to assume that we suppose that without loss of generality, we suppose that this nk is greater than uh, n, because for if it is greater than मान लेते हैं this capital N K is smaller, and we have this estimate that I have kept in box now. We have this estimate which is true for whatever nk you take, but that needs to be greater than nk. So ये nk सारे बड़े बड़े जितने भी nks larger number हैं nk से, तो उन nks में से we can choose any number which is larger than nk, so that this is possible here to modify this nk in such a way that this nk becomes larger than capital N. So what happens then? Then I can write that nk minus x is less than epsilon by 2. Now, let us look at this xn minus x, where now I'm choosing n to be any number which is greater than or equal to n. And again, we are going to take the help of the triangle inequality. For that, I need to insert a number, x and k I'm inserting. And to balance this, I have to add and subtract this number minus x. Now you apply the triangle inequality. Triangle inequality will give you this x n minus x n k plus I have x n k minus x. Now what you have here, you have this n and you have this n k, and you have n is also greater than n k is also greater than n, and what this inequality says, it says that whenever you have the natural numbers which are larger than this capital N, then corresponding the distance of the corresponding terms of the sequence is going to be less than epsilon by 2. That means uh, this number is going to be less than epsilon by 2. Similarly, from here at the top this inequality, we have this x and k minus x is also less than epsilon by 2. This is equal to epsilon. Now final equation, final inequality, what you have, we have, finally we have that for n which is greater than or equal to capital N, the distance of nth term from x is less than epsilon. So what it means, this is the definition of the convergence of the sequence. This shows that the sequence xn converges to x. Hence the proof. So this is very important result, Cauchy criterion, which establishes the equivalence of convergence with the Cauchy sequences.